comment on typical construction followed for a timber house here in New Zealand. Keep in mind that my observations are from structural point of view and they are for construction followed in the Christchurch area. This is how the building will look like once it has been completed, and we'll get to it a bit later. In this video, I will be talking about these things. I have pictures depicting site preparation. I have pictures of a complete foundation. I have pictures of the timber framing used for walls and the timber framing used for roof. And then I have a picture showing how the cavity walls are constructed in these houses. The first thing that I noted when I arrived here in New Zealand that the timber was pink. I was intrigued by the color of timber. The pink color that it gets is from a chemical treatment that is intended to increase its durability. They use pine over here. Keep in mind that I am from a part of the world where you can hardly see any timber construction in cities. One other thing to note about is that the foundation is constructed on what they call is rib-raft. It is basically a waffle mat foundation. And all the walls on the outer of the building have cavity in them for insulation purposes. A single one-story house can be constructed in 10 to 12 weeks. That's what it is claimed here. It's the construction that is followed here is very quick. Okay, this picture over here shows the excavation being done for the purpose of constructing a mat foundation. Note that not all excavation requires, not all construction sites require excavation. It will depend on the location of services like water supply and sewerage at the site. After the excavation has been done, AP65 or AP40 material will be compacted in layers of about 150 to 200 mm. These layers, they call this thing as gravel raft, and it extends approximately about 1 meter beyond the edge of the raft. They are compacted to 95% maximum dry density. The white material that you see over here, this is what is used to make a rib-raft in the foundation. They basically serve as forms. They are called polystyrene pods. Okay, this is the picture of polystyrene pods at the site. You can't see from here the voids in it. It has voids which give form to a waffle slab. And these pods are placed strategically covering all the foundation area, and the gap between these pods serve as form for ribs as well. Yeah, this is, you can see that a shuttering for pouring the concrete has been constructed for raft, for rib raft here. Yeah, this is what the reinforcement arrangement will look like in a rib raft. You can see here that these are plastic, these are uh, plastic spacers, and this is simply temperature and shrinkage reinforcement. You can't see ribs over here, but it has ribs as well, and there is a 12 mm bar placed in ribs, and there is an edge beam as well. These two things will be shown in the next picture. Yeah, you can see over here that between the polystyrene parts there is a rib, and rib has about 12 mm HD bar here. HD bar has a yield strength of about 500 megapascal. These ribs are placed on these plastic spacers, and at the ends there is a edge beam as well. It's quite wide. You can see it clearly in the next picture. Yeah, here in this picture you can see that there is an edge beam. The reinforcements in the edge beam haven't been laid at this particular site as yet, I think, because here it shows only one and two reinforcement. I doubt they will place only two reinforcement here. They will probably place four rebars there. Anyway, let's move on. Okay, this is how the constructed rib-raft looks like. It's ready to receive the timber framing. Yeah, this is the picture which shows that all the framing for the walls has been done. I see it. How do you read this framing? I see them as a series of posts which are braced in the plane of wall. The horizontal member on top of posts here is a bit deeper than the other horizontal members which are acting as bracing. It is understandable because that horizontal member on the top is acting as a drag or collector for lateral forces, and it is also required to resist out of plane bending because all the roofs here have a slope in them, so because of that it will have an out of plane bending as well. Another thing to notice is that there are no columns. Obviously it's all gravity walls which are constructed in the form of framing from pink timber. The timber here is H1.2. In addition, you can also see temporary bracing almost in every wall. This is only required during the construction phase because obviously you don't want your walls to go down in case of strong winds. They will be obviously removed when they have put in place all the roof and other things. Here you can notice that the big openings have much stiffer members for obvious reasons. Here you can clearly see that big beam over this huge opening. I guess it's for maybe, yeah, it's probably for the garage, I believe. Maybe it's a big window, I don't know. But you can see that the timber is of different grade on this opening. This, I'm talking about this one. This timber looks of a superior quality grade as compared to this timber over here, this which is pink. The pink color that it gets is because of the treatment, chemical treatment, to make it more durable. Moving on. Yeah, it's the picture of the same side showing a bit more walls. I can see framing. I can see stability bracing in almost every wall here as well. This is picture showing the framing for the walls from another side, and it shows a similar practice being followed here as well. Yeah, the same practice here as well. Yeah, it's a picture that gives a eye view, sort of bird's eye view. In this picture, you can see that at some of the locations, at some of the houses, roof trusses has also been constructed. Yeah, here you can see roof trusses have all been constructed here. Let's look at this picture as well. Yeah, here you can see roof trusses have all been erected. Thing to notice here is, although I don't have those stepwise pictures, these roof trusses, they are constructed first. They will typically construct all the roof trusses required for the site, and then they will put this connecting member at top, which will be followed by other purlins going on the side of trusses. Drawing is a bit messy, but I hope you get the message. Yeah, here you can notice that the edge or inclined member for giving the slope of roof trusses has three members. This one, because it typically carries greater compression, these members. Okay, here this diagram is there to draw upon your attention to the connections of different members within the roof trusses. Here you can see that they have used a nailed plate connection for connecting different members of roof truss together. Here is another picture that shows a number of nail plates. Yeah, this is what it looks like when they have erected all the roof trusses and the wall timber framing. After this has been done, they will put sheets on the outside of the timber framing of walls, and then they have sheets on the roof as well. And once the sheets on the timber framing of walls are there, they will start constructing these concrete block masonry on the outside. These ones, these ones. I have the pictures coming up next that will show them in a bit more detailed. Yeah, here you can see that in this side they are already constructing concrete hollow block masonry on the outside of the houses, and you can see here there is a bit of gap between the timber framing for walls and the hollow concrete block masonry, and this concrete block masonry is supported on the edges of this ribbed raft. Yeah, this is another picture showing the construction of masonry veneer, as you may call it, hollow in a hollow concrete masonry. Yeah, as I told, this is what looks like when an entire house has been built. Thanks for watching.